Hi, and welcome back to ScottiesTech.Info. I'm Scotty with my co-host Cletus, and today I want to give a brief overview of how the internet actually works. And the reason for this is many people have asked me various questions about things like bandwidth and latency and how one computer connects to the other. And so what I'm going to do is give a very simplistic and overly simplified explanation, but that will hopefully give you some terms and definitions and like sort of a broad general understanding of how things actually work. If you want to get into the nitty-gritty details of things like TCP/IP, the Transmission Control Protocol / Internet Protocol, I can link to a couple of books. They're each about 600 pages long. Yeah, if you're having trouble sleeping, you can read those and you'll be asleep in no time. But I'm not going to go into all that kind of crazy detail. I'm just going to kind of, like I say, give a very broad, simple overview that hopefully will make some sense. So, the internet consists of, it's a network, and it consists of nodes. And each of these nodes they're basically all computers. You have a laptop, you have a desktop, you have a smartphone, you have a tablet. Well, smartphones and tablets are simply computers. They're thin and they're light and they have touch screens, but essentially they're just computers. There are also servers on the internet, and servers are, again, basically just computers. They're specialized computers. They have usually things like error correcting memory, and they're designed to, they're in the shape of a rack, and so you can have racks of these servers. And but each of these nodes, each of these points on the network are just computers. Now, all of these nodes are connected together by something. They all have connections, and the connections are, it can be an Ethernet connection. If you're talking about your smartphone or your tablet, you may be connected via Wi-Fi. If you have a smartphone, you can be connected via cellular data to the cell phone tower. You're still surfing the internet, but it's a wireless connection. When you talk about the backbone of the internet, we're talking about giant racks of equipment and fiber optic cables. Your DSL line coming into your house, that's part of the network. So you have all these different nodes, and then you have all these different connections between the nodes. That actually forms the network. And when you talk about backbones, like the backbone of the internet, that's actually mostly fiber optic cables, and including, there's a giant network of undersea submarine fiber optic cables that actually go across the ocean to connect continents and countries together. On land, there are fibers that are like buried all over the territory. If you look at a map of the submarine cables, you can see that, people have been very busy. The ocean is kind of deep. So you can imagine the size of these cables. A fiber can be this little tiny skinny thing. And it's you basically shoot what amounts to pulses of light over it. And they use fibers because when you have optical fiber, you can use these pulses of light and shoot massive quantities of data. So that kind of forms the backbone. Then you have all these other nodes all the way down to sort of like the branches of a tree, all the way down to each little individual leaf. One leaf is your smartphone, one leaf is your laptop, and so on and so forth. Okay, but you've got a network and you've got all these connections, but how does any one node know where any other node is? Well, pretty much every node has an IP address, and an IP address looks something like this. That's IPv4. At the bottom is IPv6. You don't really have to understand that. All you have to understand is that an IP address it's an electronic address for each node on the network. It's kind of like a street address. So, okay, well, that's pretty easy, right? Now, each IP address is associated with a certain number of ports. Now, ports are a little bit hairy. They're kind of a nebulous concept because just as an IP address is an electronic address, a port is kind of like one way to think of it would be like it's individual little doors on the house that lives at that address. Another way to think about it would be you have a house, and into your house there is, say, a water line because you need water. You may have an electrical connection. That's another line coming into the house. You may have natural gas for heat. You have probably a telephone line, maybe cable. You have DSL over your phone lines. You have all these utilities coming into your house. You have a sewer line going out. That one's unidirectional, but it's going out. Water is unidirectional, but it's only coming in. If you have an electrical connection and you have solar panels and you generate power and you actually sell that power back to the electric company, your electrical connection would be bidirectional, because when you're consuming power, you're sucking it from the grid, but when you're generating power, you're spitting it back onto the grid. All of those connections, all of those utility connections, you could kind of group them together in a pipe. And that pipe could be your connection to the internet, but within that pipe are sub pipes, different utilities all bundled together. You could think of each one of those things like your water line, your phone line, your gas line. Those are each sort of like ports. But as I say, ports is kind of a nebulous concept. So I'll kind of give a practical example in a second that I think should make it a little bit clearer. Now, each port uses a different protocol normally. So we say that the HTTP protocol, Hypertext Transfer Protocol, that's what you use when you load a web page. And HTTP typically uses port 80. Then you have HTTPS, which is encrypted, which is so much better, and we should all use HTTPS, and that's port 443. You also have other things like SMTP, the Simple Mail Transfer Protocol, and that's a protocol that allows you to send email from your computer to somebody else on the other side of the planet. Now, SMTP, when you connect to your mail server, that typically uses port 587. But once the mail gets to your mail server, it actually has to be passed through all these different nodes of the network to get from where you are all the way over to the other side of the planet. So when mail servers on the internet itself are communicating with each other, they usually use port 25. Okay, so that's getting a little hairy, so let's have a practical example. You open up your web browser and you type in ScottiesTech.Info. Now, what actually happens? Well, we were just talking about IP addresses and port numbers, and an IP address is like a street address, and a port number is like the specific connection to that street address. And so how do you go from ScottiesTech.Info to my server spits a web page back to your browser? Well, what happens if you type ScottiesTech.Info in is you'll notice that the URL is sort of rewritten in the URL bar, and it becomes https://ScottiesTech.Info. Now, HTTPS is a protocol, and as I said, that's port 443. Okay, so now we have a port number, but we don't have an IP address because it's ScottiesTech.Info. So what happens there? Well, there's also another protocol called DNS, Domain Name System, and DNS is actually a bunch of servers sitting out on the internet whose only purpose is to resolve host names or domain names, i.e. ScottiesTech.Info, into an actual IP address. So what happens is first you type ScottiesTech.Info, then your browser goes https://ScottiesTech.Info. That adds your port number. Then your browser, if you've noticed, if you have a slow internet connection, you'll notice this more. When you press enter after typing in my URL, you press enter, and in the lower right hand corner of your browser window, sometimes you may notice it'll say looking up ScottiesTech.Info. That's a DNS lookup. And what your browser is actually doing is it's contacting the DNS system sitting out on the internet, and it's saying, hey, I want ScottiesTech.Info. What is the actual address of that so I can connect to it? And the DNS system responds and says, this is his IP address. So we go from ScottiesTech.Info to https://ScottiesTech.Info. The DNS lookup happens, and ultimately what we end up doing is your browser, after doing all that, it goes, okay, now I'm going to connect to this IP address, that port number. There you go. So the browser actually connects to that IP address and that port number, and my server sitting over in Iceland says, you want to load Scotty's website. No problem. And it spits back a web page. DNS is kind of like this resolution of a host name, ScottiesTech.Info, to an IP address is sort of like you just saying, I want to go to Bob's house. Except you have to know where Bob's house is. So with DNS basically, you ask DNS and you say, hey, where's Bob's house? And DNS responds and says, he lives at 245 Uncle Street. And then you go, great, thanks. And you drive off to 245 Uncle Street to visit Bob, who is your uncle. Okay, so that's the long and the short of it. Now, when you've actually connected to, say, my server, the web page and the style sheets and the JavaScript on the page and all the images and all the stuff that constitutes a web page will be downloaded from my server to your computer, and your web browser will reassemble it into a web page. Now, all of that stuff happens at a certain speed because we have all these different nodes in the network, and you don't just go directly to, you want to load ScottiesTech.Info. Your browser doesn't just say, hey, computer, connect directly to Scotty's server in Iceland. No. It connects to, say, your DSL modem. Your DSL modem connects to your ISP's servers. Those ISP servers can pass the connection along to different nodes in the network. This is done via something I mentioned earlier, TCP/IP. That's really hairy. But the point is that it gets bounced between all these different nodes. Finally, it gets to my server in Iceland, and then my server says, okay, shoot back the web page, and the response gets shot back through the network. Boom, your page loads. It takes a finite amount of time for data to transfer. As everyone knows, we have a certain internet speed, and we all want faster broadband. And so the speed at which you can upload something or the speed at which you can download something is what we call bandwidth. Now, bandwidth in terms of radio signals has a very specific meaning. It refers to like a specific band of frequencies, like with, say, FM radio, frequency modulation, and it gets all kind of complicated. But when we're talking about bandwidth as it relates to the internet, basically by bandwidth we just mean the speed of your internet connection. What is your upstream or upload speed? What is your downstream bandwidth or your download speed? That's it. It's pretty simple. You can go to websites like fast.com or speedtest.net, and it will tell you the upload speed and download speed of your connection. Now, in addition to the actual speed of the connection, there's also a thing called latency. And latency is, we say high latency and low latency connections. Latency is basically a time delay. Now, as I said, there's, your packets of data. Everything you do is converted into these little packets of data that are bounced between all the nodes of the network. All data traveling it's packetized, and that's one of the things that actually makes it all work. But all of this packetization and bouncing all over the place is associated with a certain amount of time. And probably the easiest way to understand the concepts of bandwidth and latency, or speed and wait time, is to look at a satellite internet connection versus, say, something wired like DSL or fiber. So here's the deal. We've got planet Earth. There's planet Earth. Earth. Now we have your house right here. And then we have here, we may have your ISP, right? Okay, so if you have a wired connection, it's pretty straightforward. I mean, there's a wire, and it runs, underground, in the air, on telephone poles or something, and it's connected through various nodes, but eventually it goes back to your ISP. Your ISP is connected to all these other places. and boom, you're connected to the internet. Now, the benefit of a wired connection like this is that it can be very fast, it can be slow, it can be fast. So we say it has a certain bandwidth, but the really good thing about it is that because it's actually wired, typically the latency, the wait time is very, very low. Well, what if you don't have a wired connection? What if it's not available where you live? Say you live out in the boonies. Well, you have no internet connection. So a lot of times what you do is you get satellite internet. Now, satellite internet, you put a little dish on your house. Beep, 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 beep. That's your internet connection. And there's a satellite up here. Literally, it's a satellite up in space, and we'll draw it like some sort of, yeah, that's not what they look like. And then way over here, possibly in another country, you have the receiving station, which is connected to the global internet. So the way that satellite internet works is you try to get a web page, and it actually has to use radio waves and beam the signal way the heck up here to the satellite. Now, this satellite is like way the heck above Earth. So it takes a long time for that signal to reach here. Because it's a radio wave, it can be, tens of gigahertz. But it's going to take a long time. As you know, like if you have a satellite TV interview, live, joining us in our New York studio via satellite, blah, blah, blah. And you notice they ask, the newscaster asks a question, and there's like a several second delay before the person on the other side of the country or the other side of the planet actually responds. That's because they're live via satellite, and it takes a finite amount of time for the signals to get way the heck up to the satellite and then way the heck back down to the base station where it's finally connected to the internet or the TV station or whatever. So the problem with satellite internet is the speed, the bandwidth can be very high. I actually have a satellite internet connection, and the download speed is 20 megabits per second, and the upload speed is 6 megabits per second. Now that may sound great, right? But there are two problems. And the first problem is that, as I said, it takes a very long time. When I request a web page, what actually has to happen is this signal takes a long time, like let's say it takes 1 second for the signal to get way up here, and then the satellite has to receive it and bounce it back down to the base station here that's connected to the internet, get the web page, and then shoot it all the way back up here to the satellite, and then the satellite relays it all the way back down to here, and finally, boom, I've got my website loaded. So we say that satellite internet connections are very high latency because the wait time, because of this huge distance that the signals have to travel way up into space and then way back down, and then the return trip, that's high latency. So when I try to load a web page here via satellite internet, it may take 3 to 4 seconds for me to get that web page, right? That's a long time. Because if I'm down here and I'm using a wired connection, the latency is like, it's like on the order of milliseconds. I click, those electrons are zipping over this wire or fiber or whatever it is really, really fast, gets to my ISP, goes out on the internet, gets the web page, and shoots it back. And we say this is a very low latency connection because there isn't this super long time delay. It's wired and it's super, super fast. So that is the difference between high latency and low latency. It's the difference between bandwidth and latency. Bandwidth is your ultimate speed, how fast are you actually downloading something, whereas latency is, you can think of it as when I make my request for some kind of data, how long am I going to have to wait before I actually get the response? Once the response starts coming, it may be shooting down at 20, 30 megabits per second, but it's that wait time that's kind of problematic, and it's why people generally don't like satellite internet, for example, because the perceived speed is very slow. When I click a URL and I have to wait 3 or 4 seconds before the page comes down, it feels like my connection is very slow. Once the page starts loading, it just shoots right down. But it's that wait time where every time you click something, you're like, waiting, and it's very annoying. So that is bandwidth versus latency. Now, there are other wireless internet schemes. There's terrestrial wireless, they usually call it, and that's basically a I used to have a service like that where you put an antenna on your house and you're actually aimed over at, say, like a cell phone tower where they have another special antenna, and it's wireless, but it's much, much faster, because the signals, instead of traveling way the heck up to a satellite and way the heck back down and then the return trip, it's basically an antenna on my house and then a receiving antenna on, say, a cell phone tower, a water tower. That is then hardwired into the internet. So the distance the radio signals have to travel is only like 1 or 2 kilometers. It's not like way up, to the satellite and way back down. So there are certain wireless internet providers that are very fast. Another example of that is, say, your cell phone. You have your smartphone and you're connected to, say, a 4G network, and you might get like, 50 megabit download speeds. That's a wireless connection, but it's very fast because the signals aren't traveling a huge distance. It's just going from here like a little, sometimes even just like 100 meters over to a cell tower and then back again. So it's still very fast. So wireless does not necessarily mean slow. It doesn't necessarily mean high latency. It doesn't mean high wait time. But in the case of, say, a satellite internet, it does, because it depends on the distance the signals have to travel. Similarly, with wired networks, with wired connections, you can have all kinds of problems. As I mentioned earlier, your packets, when you're sending or receiving data, they're being bounced between all these different nodes. One of those nodes can be particularly slow. There can be a network disruption, there can be some downtime, somebody's working on a router or some kind of crazy stuff, and then packets have to be rerouted. And sometimes they're rerouted over a different path, and that different path through the internet is making everything slower. So it gets pretty complicated. Right. So there you have it. That's the general gist of how the internet actually works. It's a lot more complicated than that, actually. There are 4 main layers. There are different protocols. There are different, when we talk about TCP/IP, that actually refers to both the internet layer and the transport layer. As I say, there's multiple layers. They're kind of intertwined in different ways. Just the complexity of the TCP protocol is literally insane. So that's the basic packet communication protocol that kind of makes the whole internet go, and it's insanely complicated. So if you really want to get into this stuff, I'll put some links to some books in the description, but it's actually amazing that it ever works at all. So anyway, hopefully that gives you a general idea of what's actually going on, and maybe in the future when people talk about bandwidth and latency and IP addresses and ports and that sort of thing, you'll have a better idea of what the heck they're talking about. So for more techie tips, see ScottiesTech.Info. Thanks for watching. See you next time.